Hello, everyone, and welcome to Lab 8. In this lab, really going to show you how to bring data in order to analyze in a couple different ways. So we're going to learn how to do uh, uh, downloading data from a remote server. We're going to just go over something you've done many times, which is loading in from a local machine. Uh, we've already pulled from some R packages that access data from an API, which is data that's on a remote server somewhere. And then I'm also going to teach you a little bit of light web scraping today. We're really just going to introduce some of these concepts, but it'll give you a foundation if you want to go further. So this lab is going to function the way the previous labs have, in which you're going to follow along with the video and run the code in this markdown file. When you see a task, that's something I'm going to ask you to do. Write some custom code. When you're done, you're going to save it and output it. You're going to put it up on GitHub, and then you're going to uh, uh, upload the links to the Markdown file and the knitted HTML file in Elms. As always, if you have trouble knitting, don't totally worry about that, or you can reach out to me for help. Okay, so we're going to load 5 packages today. The tidyverse, like usual. We're also going to load Janitor for some data cleaning. We're going to work again with the Arcos package. This is for loading data from the Washington Post's opioid repository. We're also going to load the Tidy Census package. We worked this a little bit to get information from shape files for mapping. We're going to now today use this to pull some, actual demographic information from the census. And then lastly, we're going to use a package called Arvest, which is a kind of a joke on harvest. And that's for like scraping or harvesting information from the web. Okay, so your first task is you're going to go ahead and install and load the packages we'll need. And just a reminder, if you've never installed a package on the computer you're working on, my guess is for most of you, you will not have installed Arvest, but you will have installed the other ones. You're going to actually need to go through the process of installing that. Okay, so first I want to walk through just the method that we've used kind of over and over again, which is uploading from a local machine. So in our data folder here, we have a file called Arcos WV Mingo 54059 itemized.tsv. That is a TSV, a tab separated uh, file of shipments of opioids to Mingo, West Virginia from 2006 to 2012, I think. So this little bit of code here creates an object called Mingo. And what are we putting in that object? Well, we're reading in, using the read TSV function, data, the TSV file that's in our data folder. So when I run that, it magically pops up in our environment window and comes in just like a nice spreadsheet. So you all should be fairly practiced at this point. We can also download data from a remote server if we don't want to go through the process of, say, downloading it and then uploading it on our computer. Here we can actually go out and get it and fetch it directly into R. So I'm just going to pull up this link here, and you should go ahead and click on this link at home too. And that pulls up this really kind of gnarly looking thing, but it's essentially, this is a tab separated file in which each row is, or each column is separated from the next column by a tab. And I know it looks a little funky, but the first rows are the header rows. That's essentially like the same thing as we have here. I just have it up on a remote server. So if we wanted to download it directly from that location on the internet, one of the first things we're going to do is we're just going to store an object, and I'm just going to call this Mingo URL. And the value that I'm going to assign to Mingo URL is going to be the location of that file. So there it is there. So I assign it, and now you see over in our environment window here where it says Mingo URL, the path to that file is stored there. And then next, what I'm going to do is pass to a read TSV function that URL, and I'm going to store it as an object called Mingo downloaded. So I'm saying create a new object called Mingo downloaded, and read in a TSV file. And where is that TSV file? The path to it is at Mingo URL. So when I do that, it takes a second because it's going out to the internet. And there it is, Mingo downloaded. Okay, so you have now your second task here, which is that a comma-separated value file that contains the average number of pills shipped to each county in the US per year between 26 and 2012 exists at this URL. So go ahead and open this at home. I'm going to do this here too. So here is it's going to take just a second to load. And we've got a little nicer thing here. So the first row is the header row. Columns are separated by commas, and each row is on a new line. So I want you now, using kind of this method I outlined here, to read in this file from a remote server. You're going to write the code here. One thing I want to caution you about is that this is a CSV, comma-separated value, not a TSV. So you're going to have to use a slightly different function to read it in. And if you need help with that, you might look back at some previous labs, or you might look, just Google read in a CSV in the tidyverse. Okay. Next, I'm going to walk you through some API packages. So we have already used our packages that were built to directly interface with an API, Application Programming Interface. This is a set of rules or methods that allow you to pull data down from a remote server or database in a very prescribed way. So an example we've used for the last several labs have been using the very nice R package that the Washington Post produced called Arcos that allows you to pull down the data that they have cleaned and organized from the public records dump they got from the DEA's Arcos database trapping opioid shipments. So as is often the case with when we're making use of packages that use APIs, we need to have a key. So this is the key that we're going to store here. If you go to the Arcos API R package page, there's some more keys you could use. So we see it stores there. And then we can pull down tables using different functions. So most of these packages that are built on tables using most of these packages that are built around getting data from a specific API, limit the ways you can get data. So I'm just going to pull up the page for the Arcos API package in R. And let's see, just go to the reference. There's a bunch of pre-built functions you can use to get different kinds of data. So here we're creating an object called Arcos County Pills per year, and we're using the function called Summarize County Annual. We're passing our key to it. So we stored a key up here as a thing called key. And then once it comes in, we're cleaning names. So I'm going to run that. And now we've got one record per county per year between 26 and 2014 with total shipments, that's what count is, and total pills or dosage units here. We can also pull down a table that they've prepared with county population. And so this will give us uh, one record per county per year with the population from that year. This is from the census data that they pulled this from. And in a second here, we're going to show you how to get similar information from a different R package. Okay, so you've done this before. There's no task to do here. The next API I just want to walk you through is the US Census API from a package called Tidy Census. So there's a very nice reference page here that you can visit that explains what the package is and how to access it with specific functions. You're going to have limited experience with this. We used this earlier to get the shape files that we built some interactive and static maps with. But today I'm going to show you how to actually get some demographic and economic information about places that you can use in future projects. So just as a reminder of the things that are available from the census, and this is probably not going to work super well. There is all kinds of information available from the US Census about people and businesses and places, racial information, economic information, information about poverty, information about median household income, that we can actually use to ask and answer some interesting questions. So the first thing you're going to need to do, just as we stored a key above in the Arcos API package, is we're going to use the Tidy Census package to store our API key. This is mine. You should go sign up for your own by visiting the link here. It's really easy to get one. So we're just going to store it. And then now we're going to pull down a table with the median household income for each county in the US in 2012. We're going to store it as an object called county median household income. So this is the code to do it. I'm going to run this. We're going to look at the table, and then I'm going to explain what happened here. So it takes just a second. So here's the table. We have one record per county. Just pop this out here. We have one record per county that has the GeoID, which is a unique identifier or FIPS code for each county. We have the name of the county. In this case, we've got the city, the county, and the state name combined. We've got the variable name. This is the specific code for the bit of information we're pulling out from the census. In this case, I happen to know, and I'm going to show you how you can find out, that this variable, B19013_001, is a median household income. We also have an estimate column. This is the estimate of the median household income for that county. And we have MO, or MOE, which is the margin of error. This data that we're pulling comes from a product called the American Community Survey, which differs slightly from the annual count, every decade count the census does, where they're trying to count like each house and then maybe do a little bit of estimation. American Community Survey, it's a survey like a political poll, but it's much bigger. There's much higher numbers of people who they're talking to extrapolate what the values might be for the whole country or a specific area. But there still are estimates and there still are margins of error. So this is the estimate. The margin of error uh, means that in most cases, the real value is going to fall for Autauga, Alabama. It's going to be about $2,000 a year more um, or less this 53,000. So just a little bit of imprecision baked in. Um, okay, so we fed, in order to get this information, some arguments. So get ACS is a function from Tidy Census that says get data from the American Community Survey. Now there is another function that called get decennial, and that's what you would use to get information from the every 10 years count. But the ACS tends to be a little bit more updated. We also fed it some variables. So we chose B19013_001 for median household income. But we could have picked another number, B4001_001. It would have given us total population count. Or we could have picked B06012_002 for the total population living below the poverty level. We picked the year 2012, but we could have picked a different year. Really any year between 2009 and 2019. You'll notice here, it says getting data from the 2008 to 2012 5-year ACS. So by default, when you use this get ACS function, it's really only giving you a sort of 5-year moving average of the prior 5 years. It's better to use these things, these 5-year, although you could say, give me the most recent 3 years or give me just 1 year. But the smaller the number of years you're averaging together, the higher the margin of error. The smaller the geography you're using, generally, the higher the margin of error. So you have to make some sacrifices sometimes to be able to use data that actually has meaning. The last thing is geometry equals false. If you set this to geometry equals true, it'll also deliver shapefile information along with it. These are much bigger files, they're harder to work with. So unless you really need it for a map later, I generally don't say that. Okay, so yeah, these variable numbers are confusing, right? How do I know which variables are available? Well, the census has thousands of them, and unfortunately this website at data.census.gov is not working very well. But if it was, there's an Explorer tool here. You could go in and search for variables. But there's also a way within Tidy Census. So there's a function called load variables, which pulls up a table of available variables for each census product. So here I'm creating an object called ACS variables. I'm using the load variables function, and I'm feeding it 2 arguments. I'm saying, give me the variables that are available for 2012 and ACS 5. So there's a full discussion here of what ACS 5 means, but generally it's generally it simply says we're lumping together 5-year estimates. Most variables are going to be available for any year in that time period we're looking at, and regardless of whether you're feeding it AC3 and 5. And if you have questions about, sort of what any of these things mean, please message me or, join the Hangout sessions. Okay, so I'm going to run this, and it's going to take a second, and then it's going to pop up, and I'm just going to pull it out over here. And then we're going to examine it together. Okay. So I just want to walk through a little bit how I knew that, say, B190130001 is median household income, or the B001 is total population, or 06012 underscore 002 is poverty level. So if I go to filter, turn on filters here within RStudio, and I search for median household income, we've got B190130001 is an estimate of the median household income in the past 12 months in 2012 inflation adjusted dollars. Um, why are there lots of median household incomes on this list? Well, it may be that the information is subdivided further in some ways. So if I mouse over this, um, not sure what this one is exactly. Yeah, so down here we can see this is median household income for people with mortgages. These are median household income for people um, uh, from a table that lists like household tenure. Generally, there's some kind of top line thing. And if you have a question about what you should be using, certainly you can talk with me because some of you may be using this for future products, for future projects. You can also talk with the very helpful people at the Census Bureau. For poverty, I did something similar. I just typed in poverty. And the first one on the list here is an estimate of the total of people below 100% of the poverty level. Um, there's also, more breakdowns. So people who are very poor, people at above 150% of the poverty level. Um, we also have, further subdivided things for like people who live in poverty who were foreign born. There's lots of different ways you can approach this. Uh, okay, so I have a task for you here to get some practice with using Tidy Census. Using a similar method as we used above, where we created a county by county median household income table. What I want you to do is create a table with the total estimated population of people who identify as white only and no other race in each state in the year 2014. And I want you to use that ACS 5 average, which will be on by default. So, this may seem a little bit overwhelming. So I'll give you a little hint. So if you search for this estimate total white alone um, in this label, drop that into here, you'll get the right thing to use for this. So go ahead and fill out that task. All right, so we're really just scratching the surface here of what you can do with Tidy Census. There are so many potential variables and demographics, but I just want to get you started. Okay, so now we're going to talk a little bit about web scraping. And when I talk about web scraping, what I mean here is the process of taking information that is displayed in a table on a web page somewhere on the internet and ingesting it directly into R. We're going to use a new package for this called RVest. And RVest is it's short. It's sort of a lot of R packages are puns. So this is kind of a play on harvest. And the little hex icon is a wheat, like cutting down some wheat. There's a lot of, there are a number of different language packages that exist in a variety of languages to do web scraping. In R, there's also one called Selenium that's really nice. In Python, there's one called Beautiful Soup. RVest is probably the most sort of easiest one to use. It's less flexible, but you can certainly do a lot with it. The example we're going to show here is to scrape um, this table here, which is an HTML table of opioid death rates, the rate of deaths per 100,000 person by state. You can see in West Virginia, the rate was higher in 2017 than most other states. Maryland, it was uh, uh, near the top, but still significantly under what West Virginia's per 100,000 person rate was. So this example, scraping one table, is a simple example, but it'll get you started with the concept of web scraping. And it can be a really useful thing when you're dealing with much larger tables or like tables on multiple pages. We can write a program to automate the process of collection of that data. I've scraped entire court databases this way. Sometimes in a couple cases when public officials said, we're not giving you the data, I just went out and scraped it. So that's a good tool to use. Okay, so if we look here, it's helpful when you're doing this to have some understanding of how HTML pages are structured, because what a web scraper does is it ingests the source code of a page. So if we view the page source, we can see all of these HTML tags. And somewhere on this page is the table that we want to use, we want to pull together. So there's actually an HTML table. See, it says state opioid involved overdose death rates. State opioid involved overdose death rates. So we want to, the process we're going to walk through here is the identification of like certain little bits of HTML code and then grabbing that and then sort of reorganizing it. And I can use the inspector in Chrome for this. So if you're on this page and you control right click and inspect, we can see, here's the table tag. And within the table is the head. That's the first, the top column labels. And then the body, each one of those is the individual rows that have all the information for West Virginia and so forth. So the fact that there is an HTML table on this page is very good news for us because it means that Arvest has some things built in that's going to help us. So I'm going to walk you step by step through the process of building a bit of code or a function that's going to allow us to pull this information out into a data frame that R can use. So the first thing I'm going to do is create a new object called opioid scrape, and this could be anything. And the value I'm going to assign to it is this read HTML function. That's part of Arvest. Read HTML like allows you to ingest information into R. And then the only argument that it takes is the URL. So I'm just going to run that. And so over here now we have this thing in the environment window. It says opioid scrape. It's a quote unquote list of 2. So when I pull that up, you can see it's sort of organized like an HTML document. So HTML, there's the head. The head information is a bunch of like style sheet links and things. And in the body is lots of information, different divs, and somewhere buried in here is the table that we want to extract. Okay, so now the thing we want to do is really just strip out like all that junk we don't need and really just get the table. So this is the original function that we had up top, right? To read HTML. So I'm just going to modify it slightly and put a pipe on the end here, which is the percent angle bracket percent, which means and then. So read in the HTML and then use a function called HTML nodes and just strip out the table. So now when I pull up opioid scrape, we've got the table head with our header row in there and the table body. Okay, so far so good. Now I'm going to modify our function a little more. So again, we're reading in the HTML, and then we're pulling out the table. And then we're using this new function called HTML table, which is a function inside of RVest that says extract the information from the table and put it in a format that's a little closer to what we want to use in R. So when I run that now and I open up opioid scrape, we've got a data frame with 53 rows and 3 columns, but it's not really organized exactly how you are used to seeing data frames. It's essentially what's called a nested list. So we have one string with all of our states, and the string is the state. Then we have one string with all of our rate of opioid deaths, and then some other information. Okay, so the last way we're going to modify this function is to just add this as data frame on the end. So again, we're going to read in the HTML. We're going to extract only the table. We're going to do some special magic to the table to strip out the data. And lastly, we're going to convert it into a data frame that R can understand. And now when we look at opioid scrape, it's organized like a data frame. So as you've done this, you've just completed your first little bit of web scraping. Sometimes it goes this easy, sometimes it doesn't. This data is still a mess, I want to say. Look at these column headers. This is nonsense. It also contains, like, something that actually was in our original table, which is this middle bar that says not included, did not meet inclusion criteria. There's a blank space. We got these asterisks. There's a lot of cleaning we want to do to this, but we're going to save that for the next lab, where we're going to do some data cleaning. This will be a good example. Okay, so now I want you to give this a try. You're going to do a little bit of web scraping on your own. And so I just want to show you a page here. So you're going to go to this link. And on this page, there is a table of, let's see, trends in death rates. So if I click on this trends in death rates, and then I click on this data table, we got this nice table here that has opioid death rates nationally, death rates per 100,000 people from 2000 to 2017. So what I want you to do is follow the same method I just did, and I want you to scrape this table and pull it into R. And go ahead and call this object you create opioid state scrape. Okay, after you are finished with that, then you are done, and go ahead and knit it and put it in your Git repo and upload it.